Hi everyone, this is Dr. Nak. Today we're going to learn about functions and relations. For prep work for this section, please review dividing two fractions and absolute value equations and square root property. Let's go over what we're about to learn. So we'll be learning to determine whether a relation is a function, applying function notations, determine x and y-intercept from a function defined by y equals f of x, determine the domain and the range of a function, and interpret functions graphically. Again, these are all the important things that you must know for this section. Alrighty, then let's get started. So number one, the definition of a relation. It says a set of ordered pairs x comma y is called a relation in x and y. The set of x values in the ordered pairs is called the domain of the relation. The set of y values in the ordered pairs is called the range of the relation. So given an ordered pair x comma y, your x component is called the domain of the relation, and the y value is called the range of the relation. Before we start doing some examples, let's read the definition of a function. It says, given a relation in x and a y, we say that y is a function of x if for each value of x in the domain, there is exactly one value of y in the range. So in order for us to say y is a function of x, the key point is this. Each x must have exactly one y value. So if x produces two different values, it is no longer a function. Before we go over an example, let's just read through what we're going to be learning. So we just read the definition of a relation and function, and then after we're comfortable with that, we're going to be talking about this thing called the vertical line test, and then also finding the intercept using the function notation. And the last thing we're going to be learning is the guidelines to find the domain of a function, which means that you're asked to find the domain of a given function. All right, let's get started on example number 1. Determine if the relation is a function, and first example that we're about to do is the set of all ordered pairs. We're given 8, 4, 3, -1, and 5, 4. So remember that the first component, your x values, belongs in the domain, and the y values belongs in the range. So here's what I usually do. I just write down the domain and a range. I just separate them. So who belongs in the domain? Those are all the x values, right? So we have 8, 3, and a 5. Now, what are the values for the range? We have 4, -1, and 4, but we have two 4s going on, right? So do not write 4, -1, and then another 4. Okay, so here I'm just going to write it as 4 and -1. Okay, so now I'm going to do this. So what's the relation? When x is 8, y is 4. When x is 3, y is -1. When x is 5, then our y value is at 4. So now the question is this relation defines a function or not? So you have to ask yourself, for every x, do they have exactly one y value? So every x, so 8 is going to go to 4. That's exactly one y value. 3 is an x value. Does it have exactly one y value? Yes, because 3 is going to go to -1, right? So 3 has exactly one y value. And then what about the 5? 5 is going to go to 4. So 5 also have exactly one y value. So in this case, yes, this relation is a function. Okay, so let's do another one. Now we're given 8, 4, 3, -1, and 8, -2. So let's do the same thing. Now let's determine who belongs in the domain. So all the x values are given by 8, 3, and an 8. Again, we do not repeat the 8. Okay, so here I'm going to write it 8 and 3. That's it. All right, now who belongs in the range? We have 4, -1, and then -2. Okay, so then let's make an arrow. So 8 is going to go to 4, and then 3 is going to go to -1, and then 8 is also going to -2. Okay, think about it. What do you think? Is this relation, is it a function or not? I claim no, because look, 3 is all good to go because 3 has exactly one y value, which is -1. But look at 8, right? 8 has 2 different y values, no? So this is telling us that 8 is going to go to 4 and 8 is going to -2. So that is the violation for the relation being a function. So in this case, this relation is not a function because 8 produces 2 different y values. So for example 2, we're giving city X and the number of fast food chain. So here, what are we given? We got the cities are Oceanside, Vista, Carlsbad, and Del Mar. So the Oceanside has 89 fast food chain, and then Vista has 101 fast food chain, and Carlsbad has 56, and Del Mar has 72. The first question is, write a set of ordered pairs x, y that defines this relation. So this isn't too bad as long as we realize that this side is the domain and then this side is a range. So what we're going to do is we just make a relation out of it, x, y, that's all. Okay, so here the first one is going to be Oceanside. I'm just going to write it as O side is 89. And then Vista, 101. And then Carlsbad, I'm just going to write it as C-bad, is 56. And the Del Mar, 72. And that's that. I don't know where you live, but I live in Carlsbad, and I'm not a huge fan of restaurants in Carlsbad. If I go out to eat, I usually go to Oceanside or Vista. They have better food, in my opinion. And Del Mar, I usually don't go there because I just don't want to pay Del Mar prices. But anyways, let's go. Let's go with the part B. Write the domain and a range of the relation. So again, domain is set of all x values and a range is a set of y values. So the domain here is going to be Oceanside, Vista, Carlsbad, and Del Mar. And the range is going to be 89, 101, 56, and 72. Easy peasy. The last question is, does the relation define y as a function of x? Which means that for each x, is there exactly one y value? I believe so. So in this case, I would say yes. Let's look at example 3. Given this graph, part A, write a set of ordered pairs x, y that defines this relation. Okay, so I think that portion is pretty easy. So all you have to do is just write down all the coordinates. So here you're going to have -2, 1, and then another one is -2, 3. And then we got 1, 0. And then 2, 2, and then 3, 2. So that one wasn't too bad. Part B, it says write the domain and a range. I think this portion should be okay as well, so let's go. So the domain, so let's pluck out all the x values. However, if it's repeating, you don't pick that. Okay, so here our domain is going to be -2. And then I know next one's -2, but we don't pick that one out. And then we have a 1 and a 2, and a 3. All right, and the range, what do we have? We have 1, 3, 0, 2, and another 2, so we're not going to write that 2. So there it is. Now let's go with question part C. Does the relation defines y as a function of x? So think about it. What do you think? Do you remember the definition of y being a function of x? Remember, it was for each x, there must be exactly one y value. Okay, so I claim that this is not a function because of this reason. So we have -2, right? But the -2 produces two different y values. In this case, 1 and 3. So that violates the fact that y is a function of x. Now, I want you to take a look at this graph and analyze what's going on here. Okay, so which number violates? When x is -2, do you see that we have the two different y values, right? And then there was no problem here, 1, 0, and we had no problem with 2, 2, and then 3, 2. So now, what do you notice? So if it's not a function, right, do you see that those dots must lie on the same axis? So in this case, those 2 points must lie on the vertical line of x equals -2. So do you see that if I try to draw a line through it, that line is going to intersect 2 points. However, look at the rest of it. Suppose I draw a vertical line through 1, 0. Do you see that that line intersect with a point at only 1 point? So it's 2, 2, right? 2, 2, if I draw this number line, not number line. If I draw this line, then that line intersect a point at only 1 point. Okay, so that's what we're going to talk about next. Okay, so here comes the vertical line test. It says the graph defines y as a function of x if no vertical line intersects the graph in more than 1 point. So going back to the previous example, if I draw a line straight through, let me just try to draw a line. I'm going to draw the line here. Do you see that that line has 2 points on it? So right there, we already know that y is not a function of x. Okay, and then over here, let me just draw a straight line through 1, 0. Notice that that line intersect 1, 0 only. And so same thing as 2, 2 and 3, 2. Let's take a look at example 4. It says determine if the relation defines y as a function of x. So given the graph, the easiest way to determine whether it is a function or not, apply the vertical line test. So draw a vertical line everywhere, right, along the graph. Are there any place where that vertical line has more than 1 point? I don't think so in this case because look, no matter where I draw the vertical line, let me just go like this. And no matter where I'm going to draw that vertical line, then do you see that your line is going to intersect the graph at 1 point only? Therefore, yes, this becomes a function of x. And sometimes we say yes because it passes the vertical line test. Anyways, let's do a few more examples. All right, so here are 3 graphs. What I want you to do is this: pause the video to see if you can determine whether this relation defines y as a function of x or not. Go for it. All right, so let's start. What about b? Is that a function of x? I say no, because if you draw a vertical line here, let's just say, do you see that the line is going to intersect the graph in more than 1 point? So therefore, this is not a function. Now, what about example C? What do you think? I say yes, this is a function of x because no matter where I draw the vertical line, do you see that the line is only going to intersect the graph only at one point? So yes, this is a function of x. I'm just going to write it as it's a function. Func means function. Now, what about D? What do you think? I think this is not a function because there's only one place that you can draw the vertical line, correct? But notice that that vertical line is going to overlap with the graph at infinitely many points, way more than 1 point. So therefore, it is no longer a function. How did you all do? Hopefully you are understanding this. And you know what? Let's do a couple more examples. Here are the last two examples. So what I want you to do is this. I want you to try this on your own. So please pause the video and try to figure it out whether this relation defines y as a function of x or not. Go for it. All right, so let's look at E. So what was your answer? I claim that yes, this is a function of x because of this reason. So I'm going to draw a straight line through here. Okay, that line intersects the graph at 1 point. Now, if you have an open circle, that means that your graph is not defined at that point. All right, so then here, let me just try to draw another straight line through here. Okay, so that means what? Although it's going through 2 points, but one of them is undefined. One of them is not included because this is open. So in fact, this line intersects with the graph only at 1 point, which is that closed dot right here. Okay, and then all the way along, so if I just do a vertical line test here, that's okay because it only intersects the graph at 1 point, right? And then let me just check over here towards the right hand side of it. And what about this? Again, this is okay because your function is not defined at this point. So again, it only intersects the graph only at 1 point, and then same thing here as well. Okay, so in this case, yes, it is a function. All right, now let's try F. What do you think? I say no because, let's see, if I draw the vertical line through here, do you see that my vertical line intersects the graph at 2 points precisely? Precisely, let me just change up the color, here and here. So right there violates the fact that this is going to be a function of x. Our next topic is function notation. So do you remember we usually write y equals like maybe x squared plus 3? Now, this can be written as this. You replace your y with f of x equals x squared plus 3. Now, this reads as f of x. Please note that this does not equal to f times x, by the way. Okay, I'm going to write that out. Note, f of x does not equal to f times x. Now, f is the name of the function, x is an input value from the domain, and then x is also called the argument of f, and f of x is the function value, which is going to give us a y value corresponding to x, because look, y equals f of x, doesn't it? And then again, please note that f of x does not equal to f times x. All right, let's do some examples. Example 5 says, evaluate the function for the given value of x. So we're given f of x equals x squared minus 3x, g of x equals 1 over x, h of x equals to 3, and k of x equals square root of x minus 2. So the first question is, find f of negative 5. So here what we need to do is this. Since x is being replaced by -5. Wherever you see your x, you're going to replace it with -5. But be careful, -5 in the parentheses because the negative sign is attached to 5. Okay, so then let's go. So this should be parentheses -5 squared minus 3 times -5. So which is going to give us positive 25 and then plus 15. So that's going to be 40, and that's the answer. The next one is g of -1/4. So what we need to do is we have to look at function g and replace its x with what's in the parentheses here. So here you're going to replace x with -1/4. So this x here becomes -1/4. All right, let's take this very slowly. So then this becomes 1 over -1/4. Now, don't stop there. We're still going to have to simplify this. So here comes the property of dividing two fractions. So do you all remember this? If you have a over b divided by c over d, I can rewrite this as a over b divided by c over d. Now, how do you divide a two fraction? Is you keep your first one as is, and then you multiply by the reciprocal of the second fraction. So you're going to have a d over c. Okay, let's first write down what this division is all about. So this is asking us to go 1 divided by -1/4. Now remember, 1 is same thing as 1 over 1, wasn't it? So this is same thing as 1 over 1 divided, that's a division sign, by -1/4. So now we're going to apply the property that we just wrote down. So here you just leave 1 over 1 alone. And then here you're going to multiply by the reciprocal of -1/4, which is going to be -4 over 1. That's a 1, sorry. Okay, so then what do we get? We're going to have -4 over 1, which is just -4. I just copy and pasted all the functions that was given to us, so we don't have to go back and forth. So next problem is compute h of 5. So here it is. Do you see something is a little bit different about h of x compared to the other function? So every function, right, every single function here has some variable x appearing as a part of the function. However, this guy does not have any x's attached on it. So you know what? This is a lot easier than you think. So think of it this way. This is telling you that no matter what the value of x is, your y is always going to be 3 no matter what. So here, your h of 5 is just going to be 3. Next, let's evaluate k of 5. So here, we're going to be looking at a function k, and we're going to replace its x with 3. So this becomes 3. That means that this x must become 3 as well. So this is going to be square root of 3 minus 2, which is square root of 1, which is going to be 1. Now let's look at k of -3. So again, we're going to do the same thing. In place of x, we're going to replace it with -3. So here, what we're going to get is square root of -3 and then -2, which is going to give us square root of -5. Now, can that ever happen? I don't think so, not over the real number line. However, we'll learn later about complex numbers. So in this case, we'll get an imaginary number. However, since we have not gotten to that point yet, all your answer is going to be, this is not a real number. All right, now let's look at g of x plus h. So remember, don't freak out because you have x and another variable sitting there. Just pretend that this is one chunk of a number. So what we need to do is this. We're going to replace whole thing x plus h in place of x by looking at function g. So here, this whole thing becomes x plus h, which means that this x becomes x plus h. So here, what we're going to get is 1 over x plus h, and that's the answer. Please note this, okay? So if you have 1 over x plus h, this does not equal to 1 over x plus the 1 over h, by the way. So be careful there, but anyways, 1 over x plus h is our answer. All right, now let's look at f of x plus h. So again, what we need to do is we need to replace wherever you see your x in a function of f with the whole quantity x plus h. So this x becomes x plus h. So this becomes x plus h. And this becomes quantity x plus h. Make sure to have a parentheses around it. Okay, so we got this. So let's go. So this means we're going to get x plus h squared minus 3 times x plus h. Okay, now next step, be careful. Okay, so I'm just going to write this out. So if you have like a plus b to the n, this does not equal to a to the n plus b to the n, by the way. Okay, so this means exponents indicates repeated multiplication. So what we need to do here is we need to multiply the whole quantity x plus h twice. Okay, so now, you know what? Let me just distribute the minus 3 in here. So then here you're going to have a negative 3x and then minus 3h. Okay, now what we're going to do is we're going to FOIL these two. Okay, so first what we're going to get is you multiply the first terms together. That's going to give us x squared. And the next term is you take your x, multiply that with h. So you're going to have xh. And next term is also going to be h times x. So next one is also xh or hx, same thing. So here what we're going to get is, you know what, let me just do this step by step. So here you're going to have xh, and then you're going to have another xh, and the last term is going to be plus h squared. Now let me drop down the minus 3x and the minus 3h. All right, now let's take a look at this. Remember, there was an invisible 1 sitting on the front of it, so you can still combine these two because they're like terms. So this portion is going to become x squared plus 2xh plus h squared minus 3x and then minus 3h. Do we have any common terms here? Nope. So that is going to be our answer. All right, now let's look at example 6. It says find and simplify f of x plus h. So first, we're given f of x equals 11 minus 5x squared. So now in order for us to compute f of x plus h, just like the previous example that we did together, you're going to replace this x with the quantity x plus h. So you're going to have to replace this x with the whole quantity x plus h. So let's go. So f of x plus h is going to be 11 minus 5 times the quantity x plus h and then squared. So which is same thing as 11 minus 5. Now next one is going to be x plus h, and then you multiply another x plus h because exponents again indicates repeated multiplication. So now let's just keep working. So this is going to be 11 minus 5. Now next step, be careful. You're going to FOIL the two binomials x plus h times x plus h. But since 5 must distribute to each term, you better have a bracket or a parentheses around it. So be careful right there. Okay, so now we're going to FOIL. Then we're going to have x squared. And the next one, you multiply x times h. And then h times x. And then h squared. So let me just write that out. So you're going to have plus xh, inner term is another xh, or hx is same thing as xh, by the way, and then plus h squared. Now let me just keep simplifying. So you got 11 minus 5. I don't know why I put a bracket right there. Parentheses was good enough, I guess. Then here you're gonna have x squared plus 2xh and then plus h squared. So now the 5 must distribute to each term now. So what we're going to do now is we're going to distribute the 5 to each single term to get, this is 11 minus 5x squared and then minus 10xh and then minus 5h squared. Do we have any common terms here? Nope. So that is going to be our answer. Let's try another one. So here we have f of x equals x cubed minus 2x plus 5. You know what? Let's try this on your own and see if you can do it or not. So please pause the video and try it. You got this. All right, assuming that you tried, so let's go. So here we still want to compute f of x plus h. So what we need to do is we have to replace wherever you see your x here by the quantity x plus h. So here what we're going to get is x plus h cubed minus 2 times x plus h and then plus 5. Okay, so we got little work to do here. So x plus h cubed, don't you dare distribute that 3 to x and h and be done with it. Again, that exponent 3 indicates repeated multiplication. So you're going to have to multiply x plus h 3 times. Now let me just distribute this negative 2 to each term. Then here you're going to have a negative 2x and then minus 2h. And then let's just drop down that plus 5. All right, we got little work to do, but we got this. So first, let's multiply these two together. Now, when you multiply them, you remember, you still gonna have to multiply your result by x plus h. So make sure to put a parentheses where I just underlined in yellow. So here, this is what I mean. So here you're gonna have a x squared plus, so you're gonna have xh plus another xh. So this is gonna be 2xh. And then plus h squared. Then you're gonna have to multiply that by x plus h. Now let me just drop everybody else down here. All right, we can do this. Now what we need to do is we're going to multiply these two, trinomial times the binomial. All right, so let's do it. So here, what we're going to get is the first term. So this is the procedure. If you forgot how to multiply this, you take your first term from the first parentheses and you kind of distribute it to each term on the second parentheses. And after you're done, you take the second term of the first polynomial and then you just distribute that. You just multiply it through. And then you take the last term, which is a square, and distribute to x and distribute to h. All right, so that's exactly the order that I'm going to do. So here you're going to get an x cubed and then plus h x squared. So what I have now is I just multiply x squared times x, which is x cubed, x squared times positive h. That's why I have here plus hx squared. Now I'm going to take 2xh and distribute that to x and h. So then what we're going to get is plus 2xh times x. So you're going to have an x squared times h. And then the next term is going to be 2x and then h times h. So which is going to give us h squared. Then let's take the last variable here, h squared, and distribute that to each term here. So then what we're going to get is plus xh squared plus h cubed. And don't forget to copy down the rest of it now that I'm running out of room, but negative 2x minus 2h and then plus 5. Now at the last step, we need to combine the like terms, but do we have any like terms here? So let me just check. We got an x cubed. Do we have any other x cubed? Nope. What about hx squared? Oh yeah, we have one here, no? Hx squared. So we can combine these two. Is there another hx squared? I think that's it. So here, let me just color code this. So x cubed is all good to go. He's all by himself. Now I'm trying to combine the like term for hx squared. So I have a 1hx squared plus 2hx squared. So that is going to give us plus 3hx squared. Now let's go with xh squared. So let's pluck out everybody who has the xh squared. Oh, hello, it's right next door here. Okay, anything else? Nope, that's it. So here we have 2xh squared plus 1xh squared. So that's going to give us plus 3 xh squared. And then let's see, do we have anybody with the h cubed? Nope, he's all by himself. So I'm going to copy that h cubed. And then do we have any like terms with x? Nope. So you're going to just copy down the 2x. And do we have just the h? Anybody else? Nope. So you're going to have minus 2h and then just plus 5. So that involved a little work, but look, we're done. If you got this correct, great job. And if you didn't, it's okay. Just catch where you went wrong. Catch your mistake. That's the most important part. All right, now let's play this game. Example 7, find the x and a y-intercepts of g of x equals negative absolute value of x plus 2. Now, we talked about what the x and y-intercepts are in previous section. X-intercept is where the graph is going to touch or crosses the x-axis, and similarly for y. Now, do you remember how to find x-intercept? So in order to find x-intercept, you have to set y equals to 0 and then you solve for x. And to find the y-intercept, you're going to have to set x equals to 0 and then you solve for y. So let's first start out with the x-intercept. I will write everything out. So you're going to have to set y equals to 0. But remember, y equals g of x, isn't it? So keep that in mind. And solve for x. All right, let's go. So we're going to replace g of x with a 0. And then here you're going to have negative times the absolute value of x and then plus 2. All right, then you know what? Let's bring the negative, let's move that absolute value of x on the left-hand side by adding it. So here I'm going to add absolute value of x to both sides. Then what we're going to get is absolute value of x equals 2. Now you need to drop that absolute value. So do you remember what to do? So here is the very important property of the absolute value equation. So if you have absolute value of x equals to k, that means that your x is going to become plus or minus k. All right, so with that said, this means that you're going to have x equals to 2 and x equals negative 2 as well. Because think about it, I know we did this before. So when x is 2, right, if I plug it in 2, then absolute value of 2 is 2. And then if I replace the x with a negative 2, so if I replace this x with a negative 2, what's the absolute value of negative 2? It's 2. So both answers satisfies. Now let's look for the y-intercept. So the y-intercept, so then in this case, we're going to have to set x equals to 0 and solve for y. Okay, so let's go. So here you're going to have a y equals negative times the absolute value of 0 and then plus 2. So which means that you're going to have a y equals, now absolute value of 0 is 0 and negative 0 is just a 0. So you're going to have a 0 plus 2, which is just 2. Here's the graph of y equals negative absolute value of x plus 2. So let's see if our answers are correct. So we have the y-intercept is at y equals to 2. So that's right here, which is good to go. And our x-intercept is where the graph is going to touch or the crosses the x-axis, which is here, which is negative 2 and a 2. So our answers are correct. Let's try another one. So we're given p of x equals x squared minus 5, and our job is to find the x and a y-intercept. So let's first go with the x-intercept. I'm going to write this down each time until you memorize it. So how do you find it? You're going to have to set y equals to 0 and solve for x. Okay, so y equals p of x. So we're going to have 0 equals x squared minus 5. Now let's add 5 to both sides. And then let me just swap the equation so the x squared appears first. So this means x squared equals to 5. All right, now the square root property. So that's the reason why I asked you to review these things. So please note that if you have x squared equals to k, right? Then our x is going to be, so how do you get rid of that exponent? You just take the square root on both sides, correct? But if you take the square root on the right hand side, you're going to have a plus and minus. So here, be careful. It's not just a positive square root of x. You're going to have a plus minus square root of x. So here, applying that property, we're going to get x equals square root of 5 and also x equals negative square root of 5. Now let's go with the y-intercept. So we're going to have to set x equals to 0 and solve for y. So here we have y equals x squared. So you're going to have to replace that with a 0. So we have a 0 squared minus 5. So here our y-intercept is going to be y equals negative 5. Okay, so here is the graph of p of x equals x squared minus 5. By the way, we're going to learn how to graph these things without the graphing calculator in this chapter. But anyways, so let's see if it makes sense. So where is our x-intercept? X-intercepts are here and here. So which means that square root of 5 must be here. And the negative square root of 5 is here. Now, what about the y-intercept? Y equals to negative 5. Does that make sense? Yup, here is our y-intercept. Let's do another one. So we're giving q of x equals negative square root of x plus 2 and then plus 1. So let's first go with the x-intercept. So you're going to have to set y equals to 0 and solve for x. So y equals q of x, so we're going to have a 0 equals negative square root of x plus 2 and then plus 1. Now let me move the negative square root of x plus 2 on the left hand side by adding it. So here I'm going to add square root of x plus 2, square root of x plus 2. So then what we're going to get is square root of x plus 2. This whole thing is going to equal to 1. Now, how do you get rid of that square root? Yes, you raise both sides by power of 2. So I'm going to raise here. I'm going to square it. That means I better square the right-hand side as well. Then here you're going to get x plus 2 equals 1 squared is 1. So that implies that our x, subtracting 2 from both sides, then x is going to be negative 1. Now let's go with the y-intercept. So you're going to have to set x equals to 0 and solve for y. Okay, so y equals q of x. So we're going to have a y equals negative square root of 0 plus 2 and then plus 1. So which means that y equals negative square root of 2 plus 1. So if you type in this answer, I think you're approximately, so this value is going to be negative 0.4. But please always express your answer in exact form and not decimals. Okay, so here is our function q of x. Let's see if it makes sense. So our x-intercept is x equals to negative 1. I think that's good because this spot should be negative 1, isn't it? It makes sense. And the y-intercept, I know it's really little, but this should be negative square root of 2 plus 1, which is approximately negative 0.4. Our next topic is finding the domain and a range given a graph. So let's look at part A. So let's first go with the domain. Now, in order for you to compute the domain, you're going to have to look at the x values from left to right where the function is defined. And for the range, in order for you to compute the range, or not compute, find the range, you're going to have to look at the graph bottom upwards to see where the graph is defined. So for part A, let's go with the domain. So here are all the x values, right? So where does the graph start at x equals to where? X equals to negative 3, right? But the thing is, at negative 3, your function's not defined, but that's okay. all right, as long as you can determine where the graph is starting from. Now, graph is going to start from -3. Okay, graph is defined here, defined there, right? I'm just following the blue curve. And then I know that this tail end, it looks like it's shooting downwards and then the end of it, but no. This means that this graph is going to keep spreading, I should say, spreading as x increases. So eventually this graph is going to go from, so the domain of this function is going to be from -3 excluded all the way up to positive infinity. So here our domain is set of all x values, right? But anyway, so this is going to be open -3 and then to infinity. Now, please be careful. This is not an ordered pair. So this has nothing to do with x comma y, by the way. So be careful. These are all the x values. Now let's compute the range. So now range, again, you're going to have to look at the graph from bottom upward. So where does the graph quote unquote begin? Doesn't it start from -infinity, because this tail end of the graph keeps dropping down. So you're going to start from -infinity and all the way up to where the graph ends. My apologies, this point right here should have been 3.5. So let me just write that. So this point right here was supposed to be 3.5. So here, right, your graph is going to go from -infinity all the way up to 3.5, because 3.5 is the highest point of the graph. So here your range is going to be from -infinity to 3.5, 3 1/2, same thing, and graph is defined there, so you're going to have to put a closed bracket. Now again, please note that this is not x comma y, by the way. These are set of all y values. All right, so now let's look at part B. If you want to try this on your own, go for it. Pause the video and let's see if you can do it. Okay, so let's first go with the domain. So domain, you're going to have to look at the graph from left to right. So so since this tail end is going to keep going upward, so it's basically your graph is going to start from quote unquote -infinity all the way up to, now again, this tail end is going to spread like this, wider and wider. So again, it's going to go from -infinity all the way up to positive infinity. So here I'm going to write it as -infinity, comma, positive infinity. Now let's compute the range. Again, for the range, you have to look at the graph bottom upward. So again, I'm so sorry, this dot is supposed to be touching at y equals to -3. So please pretend that dot is touching -3. Oh, I'm just going to make the dot fatter. There you go. Now it's touching. All right. So then where does the graph begin? Well, it's going to start from -3, and -3 is included, and then all the way up to positive infinity. So in this case, our range is going to be closed 3, -3, sorry, and then to positive infinity. Now let's look at part 3. We're given the step function here. So let's first go with the domain. All right, so to compute the domain, you're going to have to look at the graph from left to right. So the first left that's is going to happen is at x equals -2 and y value is 3, isn't it? But we only care about the x value for now. So here our graph is going to start from -2, but -2 is excluded. And then all the way up to -1, because it's defined at a -1. So for that portion, we should be able to write this as open -2 to -1, but function is defined at x equals to -1. So I'm just going to put a bracket around it. And then you look at the next step. So the next step function here, it's going to start from, remember, we're going from left to right, right? It's going to start from -1, but -1 is excluded. And it's all defined up until x equals to 0. And corresponding value is y equals to 1, but we don't care about that for now. So here, your function is defined from open -1 to closed 0 as well. So here, let me just write it as union. And then -1, comma 0, closed. And then we have one more graph right down below. So let's take a look. So here, our x is going to start from 0, x equals to 0, but 0 is not included. And then it's going to go all the way to +2, and +2 is included. So here, you're going to have to union it with 0, comma 2, closed. So that will be the domain. All right, now let's go with the range. So don't freak out, we got this, okay? So for the range, remember, you got to look at the graph from bottom upward, right? So where is the graph defined? Well, I think graph is only defined at y equals to -2. Although this is open, it's okay, because think of it this way. You can easily look at the graph from bottom upward from this side. So first of all, your y value is going to be -2, but are there any graphs in here between? No. So our answer is going to be just the singleton -2. So to write that, just put it like this. So curly bracket -2, or you can just write it as -2, and that's totally fine without any bracket. And then let's keep going then. Now what? Now where's the next graph? Well, next graph, your y value is at 1, isn't it? Because if you go, there's nothing in between, but we're still computing bottom upward. So again, it's just going to be a singleton 1 here. So let me just write it as 1. And let's keep going with the same argument. Next graph is going to start happening at y equals to 3. But there's nothing in between here, right? So your next function is going to be defined here, which means that you're going to get a singleton of 3. So here our answer is going to be 2 union 1 and then union 3. This was the little tricky and strange looking one, but I just wanted to do it with you all. How you all doing up to here? Are you doing okay? I know this section is so long, so hang in there. So let's take a look at the next example. Example 9, we're asked to find the domain of a function f of x equals x plus 7 over x minus 3. Now, in order to find the domain, you got to get your restriction. So let me just write. So what is the restriction here? You're given a fraction, right? But remember, you can never have a 0 on the bottom of the fraction. So that's going to be the restriction here. So the restriction is that the bottom meaning denominator, cannot be 0, which means that the x minus 3 cannot be 0, which implies that x cannot be 3. I don't know why I wrote that in purple, but oh well. So here is the only restriction. Now, this is what this is telling you is this. Your function f of x is defined for any numbers except for at x equals to 3. So in order for us to write this, the domain in an interval notation, to me, easiest way to do is just draw the number line. And here is our 3. X cannot be 3, so I'm going to have an open circle around it. And your function is defined at all shaded area. So just translate that below, then you're going to have negative infinity to 3, open parentheses, union, open 3 to positive infinity. Let's look at the next one. We're given g of x equals x plus 7 over, now the denominator is x squared plus 3. So again, we have to look for the restriction. So the restriction on the fraction is the bottom cannot be 0, right? Which means that x squared plus 3 cannot be 0. But Isn't that always true? Because think about it. If I solve for this, you're going to have an x squared equals to negative 3. If you square any number, can you get a negative value for the real numbers? No. So in this case, it tells you this: no matter what value that you're going to plug it in, your denominator will never go to 0. So which means that there are no restrictions here. So our answer is going to be all real numbers. So how do you express that in the interval notation is from negative infinity to infinity. Let's look at the next problem. So we're given p of x equals square root of x minus 10. So we got the square root going on. So what is the restriction? Yes, the radicand must be greater or equal to 0. You could never have a square root of a negative number over the real number system. So here, restriction is that the radicand, which is x minus 10, must be greater or equal to 0. Now, adding 10 to both sides, then we're going to get x is greater or equal to 10. So that is going to be the restriction. So to express this as an interval notation, let's just bust out the number line. Here's negative infinity, positive infinity. This is 10. So x is greater or equal to 10. So you're going to have a closed bracket. Or you can have a closed dot if you want exactly the same thing. And x is bigger than that. So you're going to be shading this side. Translate it directly below. So the domain is going to be closed 10 all the way up to infinity. Let's look at the next example. We have s of x equals x squared minus 4x minus 12, whole thing divided by x plus 1. Now, in this case, we don't need to factor the numerator because all it really matters is the denominator. But I don't know how your skill is when it comes to factoring, so can we factor this together? Let's try it. Okay, so let me just write down x squared minus 4x minus 12. So I want to factor this into two binomials, and each one of them must start from x, because if I multiply the first term together, you're going to get an x squared. I don't know which way you learned how to factor, but a lot of my students like this method, so just go with it. So here, I'm just going to draw the x, and here I'm going to have c and a b. What the heck is c and a b, right? So a is the coefficient on x squared, b is the coefficient on x, and c is the constant term. So here our constant term is 12, and then our b is negative 4. So now what we need to do is this. We need to pick two side numbers such that when you multiply them together, you're going to get negative 12. But when you add them together, you're going to get negative 4. So first, I usually determine the sign first. Is it positive, positive, negative, positive, and so forth. Now, if I multiply these two numbers, it must be negative. So do you see that I must have positive and negative? It doesn't matter. You could go negative, positive. It doesn't matter. So here, I'm just going to write it as positive, negative. Next, write down the factors of 12. What times what equals to 12? So it's 1 times 12, 2 times 6, 3 times 4, and then it flips, right? So these are our only choices. So now what we need to do is this. You take your first 1 times 12, so you put 1 and 12 in here. 1 minus 12, if I add them, do we get a negative 4? No. So then you go 12, positive 12, and then minus 1. Is that going to add up to negative 4? No. So this combination is out of there. Now let's play with 2 and 6. So if I put a positive 2, negative 6, is that going to add up to negative 4? Oh yeah, it does, doesn't it? So let's just write it as 2 and a 6. So here, if I multiply positive 2 times negative 6, it's going to be negative 12. And if I have plus 2 minus 6, that's going to be minus 4. Now, what the heck does this all mean? So what's going to happen is this. These side numbers are the one that's going to go into each of the parentheses. So here, what we just discovered is this. Let me just write it out. So if I factor the numerator, then here what we're going to get is x plus 2 and then x minus 6. And then whole thing divided by x plus 1. Again, you did not need to factor the numerator to do this problem, but I just wanted to practice how to factor with you all. Okay, so now let's go with the restriction. So what's the restriction is that the bottom cannot be 0, which means that x plus 1 cannot be 0, which means that x cannot be negative 1. And that will be the only restriction here. So let's just draw the number line again. Here is negative 1. X cannot be negative 1, but x can be anything else. Translated directly below, we're going to get negative infinity comma negative 1 open union negative 1 to positive infinity. That's going to be our answer. Okay, now let's look at the next example. We have t of x equals x plus 1 over x squared minus 4x minus 12. So that's just the reciprocal of example D that we just did. So we already factored that earlier, so let's just rewrite this. So restriction is, well, before we do the restriction, let's just factor. So you got an x plus 1, and we just learned how to factor this. So this is going to be x plus 2, and then x minus 6. So the restriction is that the bottom cannot be 0, which is x plus 2 times x minus 6 cannot be 0. Which means that x plus 2 cannot be 0, or x minus 6 cannot be 0, which turns out to x cannot be negative 2, or x cannot be 6. So those are the restriction now. Now let's try to write the interval notation for that. So here's my negative infinity, positive infinity. So let's just say this is negative 2 and this is 6. Now x cannot be negative 2, so I'm going to have an open circle here, and x cannot be 6. I'm going to have an open circle. But all the rest of it, your function will be defined. All right. Translate it directly below, then what do we get? Negative infinity to negative 2, open, union, negative 2 to 6, open, union, and then 6 to positive infinity. Now, it's so important that you know how to factor. So if you need extra problems or extra practice, please let me know so I can pick out some great problems for you to relearn how to factor. Let's do a couple more examples to get good practice here. So here, h of x equals negative 5 over square root of x plus 20, and then minus 1. Now, can you see how many restrictions that we're going to get here? I say 2 because first you have a fraction going on, which means that the whole bottom cannot go to 0, right? However, you also give in the square root. So the radicand must be greater or equal to 0. So let's write that out. So the restrictions, so the first one, let's just take care of the radicand so that I know for sure that the radicand must be greater or equal to 0. Subtracting 20 from both sides, then we're going to have x must be greater or equal to negative 20. So that's one of the restrictions. Let me write that as circle 1. And number 2 is the whole entire denominator cannot go to 0, which means we're going to have x plus 20 minus 1 cannot go to 0. Now, adding 1 to both sides, then what we're going to get is square root of x plus 20 cannot equal to 1. Now, let's square both sides to get that square root. So here you're going to have x plus 20 cannot equal to 1 squared, which is still going to be 1. Now, let's subtract 20 from both sides to get x cannot be, what's 1 minus 20? Negative 19. All right, I think we got this. Okay, now let's just draw the number line. And what's going on here? X must be greater or equal to negative 20. So we have a negative 20 here. And then negative 19 better be on the right-hand side of negative 20. So here is negative 19. Okay, so X must be greater or equal to negative 20. However, X cannot be negative 19. So which means that I better have an open circle around negative 19. All right, now translate it below. What are we going to get? Closed negative 20 to negative 19 open. And then union open 19 to positive infinity. So here's the graph of our h of x. Let's just see if it makes sense. So here, right, I know that you can't see where this graph is going, but it's just going to go upwards, but it's never going to touch this x equals negative 19 axis. So here, do you see that our x is going to start from negative 20, and this tail end is never going to touch the negative 19 axis. And then for this tail end also, this if this graph keeps going downward, it's never going to touch x equals to negative 19, which means this axis right here. So it does make sense. So the domain is going to be from negative 20, and we have to skip negative 19, and all the functions are defined from there on. All right, let's look at the last problem here. So we're given f of x equals 3x minus 7, where x is strictly less than 0. Now let's talk about 3x minus 7. Isn't that a polynomial of degree 1? Because the exponent on the x is 1, so that this is a polynomial. Now, one thing really good to know is this. The domain of the polynomial functions are always going to be all real numbers. So let me just write that out. So domain of a polynomial, is it okay if I write it as poly, is always going to be from negative infinity to infinity, no matter what. So for example, like if you're given like maybe 3x squared minus 5x plus 1, let's just say, what's the domain of that? The domain is going to be all real numbers. So because that's a polynomial, negative infinity to infinity. Now, what makes it not polynomial is this. Suppose your exponent is negative, or your exponent is a fraction. Then that is no longer a polynomial. But anyways, so here we know for sure that the domain of 3x minus 7 is all real numbers. However, we have the restrictions going on here. This is telling us that but x must be strictly less than 0. So if I try to draw that out on the number line, now this guy 3x minus 7 is defined for all real numbers. No matter what value of x you're going to plug it into 3x minus 7, our function will be defined. However, x must be strictly greater than 0 now. So suppose this is 0, x must be strictly less than 0. So here, you're going to have an open circle, and x is less than, so we're going to have to shade this region here. So where do they overlap? It's from negative infinity to 0, excluded. So we're going to have a negative infinity to 0 open. How y'all doing up to here? I know that this was such a long section, but this, knowing what is a function or computing the domain of a function is extremely important in pre-calculus and calculus as well. So great job. If you watch this whole entire video, I swear you are such a trooper. And also, don't get disappointed if you didn't know how to factor, or if you are still a little bit confused about how to find the domain of a function. Please know that I'm here to help you with that. And I understand how difficult it can be, because when I was a student, I had to take the same exact course twice. and I had the most difficult time finding the domain of a function. So I feel your pain, but please know that I'm here to help you. So if you have any questions at all, please let me know, okay? But anyways, great job, y'all, and I will be talking to you during the next lecture.